Hi all, this is Vishal Singhal from CellStrat, your host for today. And today we have Mr. Akarsh Verma, consultant Thoucentric. He was with us until recently in Gurgaon in our CellStrat AI Lab, but now he's shifting to Bangalore as soon as the lockdown opens. And he'll be presenting us with this random forest topic today. Is Akarsh, are you ready? Akarsh? So just give me a moment. There seems to be some technical issue he's facing.
Hey, hi Vishal, can you hear me? My name is Akarsh Verma. I work at Thoucentric and I'm a technology consultant. I've been in the industry for about 9 years now, and I'm an enterprise architect by profession, but I do machine learning and I look at whole data pipelines. So now starting my content and cool. So the whole idea of jumping to random forest is we need to understand a little bit of what and why random forest exists and what kind of problem does random forest intends to solve. Now, if you think about it, there are two problems effectively in machine learning scenarios that we usually deal when we are predicting something. We call that regression, and when we are trying to fit something into a different class or multiple classes, we call that as a classification problem. Most of you guys might have encountered when you would have started your journey with machine learning, either a Boston housing data set, which is for regression, or a Titanic problem, which is for classification. Now, this diagram is very intuitive and is actually talking about a lot of things. And I thought of putting uh, more information, but I want to stick to this. Now, this is a very simple thought that different people are classifying, and effectively, in their own essence, in their own isolation, they are all right, right? And this is a very good summary of the idea of a random forest, which effectively is nothing but, I wouldn't say nothing, but it's effectively a lot of different decision trees combined in some fashion, be meaned out or something. But a classification problem effectively is to identify whether this is an elephant or not, right? You could also think that we will try to identify what kind of elephant it is and blah, blah, blah. That's, we are not going to get into it. So if you think, it's a super simple question, is this an elephant or not? So it's a binary classification problem. But if we further define it and see it in some essence, all of these guys that are looking are also right in their sense. So they are also doing some kind of a multi-class classification. And though neither of them are right, but they have got individual features right eventually. And there's a lot of variance in the way they are describing their things. If they're specifically looking at it, a guy is calling it a brush, a trunk, but it is neither, it's an elephant. So the whole idea of classification revolves around this good imagery, and a classification problem will effectively help you determine whether this is an uh, elephant or not, in which case we will call it as a binary classification problem, kind of a 0 and 1, or class A or class B, red, blue, cat, dog, something like that. Or it could be a multi-class classification problem where you have a different classes. It could be red, blue, green, and you need to put your data into all of them. And again, there could be different variations of it. If you have three classes, you could be saying red versus all other, which will make it a binary classification problem, versus red, green, blue, all three, which will make it a multi-class classification problem. So in essence, what we are talking about is a classification problem, and there are different algorithms to work with classification problems. Uh, Tree-based algorithms are one of the most important algorithms that are usually studied, and they're pretty accurate or usually right. One couple of other algorithms which are used very actively in classification is support vector machine, and you also do a little bit of probabilistic classifiers like Naive Bayes or logistic regression. But tree-based algorithms have a extremely nice sorry, the word is actually, I'm sorry, I'm missing the word. It's basically you are able to explainability. Yeah. So the explainability of a tree-based algorithm is extremely high, and hence they are popular even in industry, and a lot of people rely on it. So just a summary slide on to set the context. We are going to be talking about tree-based algorithms, random forests to be specific. We'll go there, we'll jump on it, do a little bit of coding there, and we'll slowly build on that. All right. So, Vishal, can I assume there are no questions till now?
Yeah, yeah, good. I'll ask you
All right,
in
cool.
there.
Cool. So, tree-based algorithms are effectively what we think of them. They are effectively tree-based, and you can visualize it like this. You could think of them as a single tree, or a decision tree would be multiple different trees, or like random forest in the scenario. And random forest is nothing but multiple decision trees. They are shuffled together by randomness, and then you typically find some kind of an average over the different trees, and then you explicitly state that okay, this is the accuracy of the decision tree, sorry, of the random forest. So these are tree-based algorithms. The way they behave is something class probability is something what we predict. Let me see if I have, yeah, I have a slide for that. So what these numbers represent, the CA is less than 0.5, less than 0.5, and then different parameters. These are called class proportions. And effectively in classification problems, we are usually interested in knowing the class proportion for a particular region or a particular sample of the data as to how it is flowing into different classes. We are going to be taking of an iris dataset example, but which is three different flower colors and things like that, and dimensions, and that's what we intend to find out when we do a decision tree or random forest as to what class proportion my data is usually picking. Now, there are different entropies or mechanisms, I would say statistical mechanisms that are used to calculate it. One of the most popular is, did I put Gini Index? Yeah, just one second. I should put Gini Index first. 52. All right. So one of the most popular is Gini Index, which is more like a probability based. It predicts the probability, or it tells us how much my data is fitting into a certain class, and it is just some one minus sum of squared of probabilities, which we will see in the next slide. Now, there are different kinds of errors, as I stated. One is misclassification error, Gini index, cross entropy or deviation. But usually the Gini index, which as I said is the sum of squared probabilities for each class minus one minus that is what is most of the times used. And a tree, the balancing of a tree can be changed by the mechanism we use to balance it. It could be Gini or it could be cross entropy. Again, we'll see that in the diagram. This is what is called Gini index. Again, as we were trying to say, it is the proportion of observation in the mth leaf of the class. Now, the whole formula is not as such important, but we need to understand that the smaller the value of the G, the more purity there is in the node, which means that the that specific node has higher accuracy. And we'll see it in the in a tree example. For example, just bring that out. So you see, this is what we will be generating right now, and it says here Gini is 0.5 and then 0. And then further it goes on into different trees for the iris dataset. So this is the index which is used usually to balance out decision trees. And the reason I'm talking about decision trees is decision trees are pretty much the most basic way of tree-based algorithms. They effectively define the underlying principles of random forest or any other tree-based algorithm. Now, let's just see this example of cancer or no cancer patient. So there's a leaf, and the center, the circle is called a node, and then all of these branches are called leaves. And so the node has two data points, which is, let's say, male and female. And for female, it is just simply specifying that the female branch has cancer. But for male, there's a further bifurcation, which is age less than 30 and age less than less than 30 or more than 30. And then you define that, okay, cancer exists or not, doesn't exist. Now, for each of these nodes and leaf, there is a weight assigned, which is the Gini index, as I was describing before, and that effectively determines which class my data is going to flow. So if I get a male tomorrow who's having an age group less than 30 or equal to 30, using this decision tree, we'll be simply able to traverse down and we'll be able to tell that the person has a cancer or not. This would be not the best of ways to do it, but this is from an explanation standpoint is extremely intuitive and visual. This is usually what a decision tree is. Now, a couple of challenges that we have in decision trees tend to learn the data very fast, which is to say that they have high variability and they are effectively not, though we can implement shuffling and we can do certain techniques, which we'll just talk about after this, but they are very much prone to an error, or they are very much prone to, let's say, low accuracy scenarios, especially when data is large. And the reason I say large is simply because what will happen is your decision tree is going to learn the data, is going to memorize the data, which is not so good. You can do that by, you can reduce that by cross validation techniques, shuffling of your data, but effectively a decision tree is one of the weaker tree based algorithms, but is the starting point on studying tree based algorithms. Now, effectively, exactly what I was trying to explain before. A decision tree has an extremely high variance because of the way it calculates. It's a pretty simple mathematical operation balancing act. You can write a decision tree in raw numpy instead of using sklearn pretty easily. Now, the standard approach to reduce this variance is to do some data sampling or to do some randomization of the data, which is very difficult in actually production scenarios. Because what happens is what you're doing is you're asking for more data, which is usually not available. In the case of a production, I know I said before that for larger data sets, it tends to learn. But what I was effectively trying to say then is that when during training, if you have a large data set, it will learn that. And in this scenario, what I'm trying to explain in this slide is that you take completely independent sample from the population to reduce the variance. And I hope everybody understands the word population and independent sample, which is, if somebody has a question, please put it in the uh, chat. Vishal, is anybody asking that or not?
None as of now.
Okay, cool. So that's fine. So I'm assuming you guys understand population and independent sampling. So we'll and why it is helping to reduce the variance of a decision tree. And this is usually not possible in real business scenarios because business usually doesn't have a lot of data when you're doing these exercises. But we solve these techniques by bagging methods or different tree decision improvement methods, let's call them. And these methods just help and focus towards reducing variance. In certain
Akash?
scenarios, the decision. Hello.
Uh, so somebody is saying, please explain. So probably is asking for population and sampling.
Okay. So
Yeah. And
population is.
also,
Mhm.
another follow-up question: in which scenarios we use random forests?
Yeah, I'll come to that. I'll come to the scenarios part. Definitely, I'm trying to go to the code pretty quickly, but I'll address the first one. So population is just your data, your original population. Think of it as your country's population, or your factory is, let's say, producing something. Let's say your factory is producing a product A, and it is producing 10,000 of it. Now, what you could be doing is you could be interested in figuring out some kind of a defect for your production line. For example, let's say you are manufacturing biscuits and somehow the biscuit packaging is getting destroyed for some certain scenarios, probably because of some problem with the pipeline, or it could be a temperature setting or anything like that. So what you will do is you will take a sample and you will try and model it. What independent sampling is referring to here is whatever sample you have taken to train the decision tree, it's absolutely fine that you do that. Then you take another sample from the production line, which is absolutely not connected to your original data. And this implies not the testing and training split. It's usually completely not since data. Probably you took the data A, the sample A on a day one, and the sample two could be day five, something like that. So those two data sets should not we have some sort of a, let's say, sampling error in the sense of taking out and extracting the data. And what you do after it is you take that new data and you effectively also use it to pass it into your decision tree and then see how your tree behaves. Usually, this exercise is not possible when you deal with decision trees and classification based algorithms. Hence, we jump to a more robust form of algorithm or other algorithms. Either it could be tree based or it could be non-tree based algorithms as well. So I hope that loosely answers the question. Bagging methods is out of the scope for this discussion. They are techniques. They are randomization. They are techniques. They are sampling techniques that effectively help you improve a decision tree quality uh, by introducing a sense of variation in the data. So that allows the variation to accommodate for the lack of accuracy in training decision trees. Now, that's usually uh, uh, the best I can go about decision tree, and we will we will simply go to random forest, and this is more of a pictorial representation of a random forest. Now, a random forest, there are different trees, and the way it behaves is imagine different multiple decision trees acting and operating independently, and then each tree gets some vote, or each tree gives a probability, or each tree gives some sort of a contribution towards the actual target class. Now, this is a generically, now this basically introduces some complexity and explainability, which is you cannot draw out a random forest that easily like you could do a decision tree. However, what has happened is you have reduced the chances of having variance errors that the decision tree was allowing because of techniques of selection of model, not of model, of the actual output. So effectively what will happen is you will have, let's say, 5 classifiers, number of trees, and then each tree will give some weight, and then you will take out an average roughly, and then you will come up with that number. And usually it is an understanding that that number, that accuracy is better than that of a raw decision tree operating independently. However, this varies case to case. Okay, so this is a little bit of introduction about random forest. From a slides perspective, I don't have anything else. I will jump to the basic, some standard code that is there. Again, this code is not to test out anything. This is a pretty basic introduction and example for a random forest based approach. So I've done it on top of an iris dataset. I hope everybody is familiar with iris dataset. I'll just probably bring it up uh, for discussion. All
Akash,
right.
can you repeat?
So
Akash, can you repeat that random forest is? You said something.
random forest is, sorry.
You, can you please give a real-based problem statement where we can define how to use random forest?
So so are you trying to, whoever is asking this question, are you trying to understand when would you use a random forest
Yeah,
versus a
real use
decision?
case.
So, okay, a real use case is simply, as I was saying, let's take a factory production line, and the algorithm choice is really dependent on the accuracy. It's not uh, pertaining to a problem per se, but I'll probably describe a kind of problem which you could use. So the okay, let's take that plant example that I was trying to say. So I have a manufacturing plant which is manufacturing, let's say teacups. Okay, let's for better classification. There are three different colors that I make: white, black, and red. Okay. Now, what could be happening is that the red color was getting some defect, or the white color was getting some defect, or the black color was getting some defect based on different parameters of my assembly plant. It could be temperature, it could be humidity, it could be electrical current, it could be some other pieces of machinery. So whatever data is it that I'm collecting, I need to feed it to a machine learning algorithm in order for it to classify the defect, and then probably we could go back and tune those parameters again. Let's say the humidity, the ideal temperature range for coming up with a red cup is 25 to 30 degrees centigrade. Now, if my temperature sensor was reading 31 degrees centigrade, it could mean that my red cup could get a defect, probably a bubble or something. Okay. So what will happen is the data would flow in from the plant. It would go to a system where the algorithm and the model is running, which has been pre-trained, and it will give me an output that this is not the ideal temperature range. Go back and correct the temperature range to not have a defect in the production line. Now, this is a practical industry classification problem in manufacturing. You could also have different problems like customer segmentation. For example, you have customers who are buying mobile phones less than 10,000. You have customers who are buying mobile phones less than between 10 and 20,000. And then you have customers who are buying above 20,000 and probably then above 50,000. So you have four categories. And then you could have different data for them. You could have their past selling history. You could have their monthly earning. You could have their current EMI. You could have their spouse's earning. You could have their number of children and things like that. Now, you would want to classify based, you have some past data with respect to that, that these people were purchase these kind of cell phones. Tomorrow, if I come to the shop again, you would want to classify that what kind of a customer I am so as to give me the best offer, and which category I fall under. Probably if I'm a cheap customer, less than 10,000, you will give me a EMI offer. If I am 10 to 20,000 customer, you would just give me the best feature phone. If I'm a luxury segment customer, you would probably try to sell me more accessories. So a real life industry problem is customer segmentation, where you can really implement a lot of classification techniques. Now, these algorithms, tree-based algorithms, are very popularly used because it is very easy to explain it this to business from a data scientist perspective that, hey, this is what is happening in your data. And when a customer is having, let's say, a monthly salary of 50,000 and his spouse is earning more than 50,000, and in the past he has purchased an iPhone, then he is a classification customer. Sorry, then he is a luxury customer. So this is a classification example that can be implemented using any of classification algorithms. The benefit of using random forest or decision tree here is decision trees accuracy in general. It is more white box in the sense you understand what is happening, but you typically have some accuracy loss. At least in the problem that I stated, I have worked with this kind of a problem in the past, and we were typically ending up with, when we were doing this explanation and decision tree, we were ending up with 94, 96% accuracy. But when we implemented random forest, the data, of course, the variance and the things that I talked about reduced, and we were able to pretty much take the accuracy to 98 plus percentages, which was significant gain from a decision tree based approach. So the trade-off that comes is, it's not that neither of them will give you will not give you an output. They will give you an output. It's just the accuracy and explainability which is needs to be balanced, and that's pretty much an industry use case that I can share right now.
Another question,
Okay,
Akash have just shared it in chat.
what does it create random forest which rows includes how many observations? If I have 1.2 million rows, 500 columns, how does it create? So, okay, random forests, you can specify these parameters, buddy. So the depth of a tree and the number of different trees that you can use, you can specify in a random forest classifier. Let me see if I have used it, or probably I can show it on scikit-learn itself. So, so you see criteria Gini, this could also be the entropy. The max depth is basically the maximum depth of the tree, whether how many layers you want the tree to go. And the number of estimators is the number of forest in the tree. Now, again, this is something I cannot give straight away as an answer to you, but these three parameters are typically what we play with. Again, we do sampling techniques also, but the rest of the information is for sampling and other parameters, which I also do not know. But the first three are pretty widely used. You either specify Gini or you specify entropy. Again, the default I have gone with this Gini. Max depth, as I said, is the depth of each tree, and an estimator is the number of trees. So for your example, I think let me see how much you said. So if the number of rows is fine, 500 columns. I do not know. You'll have to train a tree and see which what it gives you better results. Probably 500. If you have 500 columns, you could also look at doing some feature engineering if you really want to use random forest. Feature engineering, I will show you how it influences the classifier shortly, but I cannot give you a straight answer as to how many trees you should use while looking at this. But the parameters that you need to play with exist in the code. All right, coming to this example, and we'll probably do Q&A again in between. Now, all I'm doing here is just picking some data, loading iris using sklearn datasets. The sklearn import tree, graphics, these are all visualization to visualize a tree. Now, decision trees can be visualized, and the random forest can also be visualized using a technique which I forgot. It's extremely sorry, it's off the top of my head. There's a mechanism to visualize random forests also, but I've never really understood it. Yeah, this one, orange. This is typically how a random forest is visualized. I think each of these tentacles are individual trees, and the color saturation represents basically the classes and how much depth. Sorry, not the depth. The color saturation represents as to how confidently or how deep that specific class is going into each. This is available on Orange, and it's more used for biostatistical simulation. I have personally never understood how to understand this and infer it. It's too complex in terms of explainability. But the mechanism exists. If you just Google it, you will get this. Now coming back to the code, again, I'm just loading Iris dataset, putting it, there are different target names, and I'm just printing out the data, putting it into different data frames. So you have sepal length, sepal width, petal length, and petal width, and the species, which is categorical variable, which is the what we need to train upon, and which is what we need to classify upon effectively. This is a train test split, standard 70-30. I've done a simple decision tree here, which is what is pretty interesting. Now, if you see this decision tree, it says that petal length with less than 0.80 centimeter is class 0. If it is greater than zero point 0.8, then you follow different parameter. Again, if it is greater than zero point 0.8, then is it less than 1.75? Then it is class 1. And then if it is more than 1.75, it is class 2. This is a simple, this is very easy, right? You get to explain. Now think of my customer problem. Usually what happens is it's very easy to explain this to business when you are dealing with non-technical people, or because you cannot just give them something and assume them to use. They will want to understand what is happening behind, and this comes very handy. This is effectively the visualization that is happening. Now, if you see again here, it's zero point 0.8 less than equal to zero point 0.8 and true and false. And then it is further bifurcating into different branches and all. But at a high level, it's just stopping here in my code. But overall, it is showing you to the depth at which the tree is going. So in totality, it has one root node and then one, two, three, four, five layers of depth, which is effectively what you control in a random forest as to how many of trees like this and how much the depth of each tree. For you can go up to 100, 200, I think goes up to 100. No, there's a limit at which, yes. So it is 100 trees. The depth doesn't have a limit parameter. I do not know that if it has, but usually three depths more than two digits or two digits are pretty useless. I personally only stop till 6, 7 layers. That's it. It makes no sense for a random forest to be made up of 20 different trees having 20 layers of depth. It loses explainability again. Now coming to the random forest classifier, the code is pretty simple. You train a classifier, CLF is equal to random forest, number of trees 100, estimate is 100. I can make this 10, wouldn't matter. And then I get some accuracy, right? I get a 0.93, which is 93% of accuracy score. And do a prediction, which is pretty fine. Now, then I do so somebody was asking the 500 column person, right? Okay, there's a question. Let me take that before. Does each n estimators will have all 500 columns? To the best of my understanding, yes. Uh, each tree gives its own individual weight. So yes, each tree will get all of these parameters. I have honestly not worked if there's a way to reduce that for trees. Let's see if it is possible in the documentation. Meta classifier. No. I do not see how you could do that. You have some sampling techniques, but yes, your each tree will get those 500. And again, but you'll have to understand the same rows will not go into that. Even though 500 features are going into that, the same rows are not going into that. So the output coming out of each tree will be very different. And the target class prediction that that specific tree does will be very different compared to other trees. So in essence, each tree, even if it gets the same features, is not going to give you the same classification or class proportion effectively. And which is okay. There's a follow up to this. Will you be able to show it? This notebook is pretty simple. Yeah, sure. I can send this to Vishal and you can pick this. You will find this code all over internet. This is, in fact, half of the code is from sklearn library. There's not a lot of stuff that I've done here, but yeah, happy to share it. No problem. Uh, in fact, let's do this. Can I make it public via some mechanism? Okay. Share with people. No, I don't think I can make this public. No, I cannot make this. I can copy a link. Vishal,
Yes,
I'm pinging you this.
yeah, share the link. I'll
Uh,
put it on the chat.
I organize and panelist. So you should, everybody now should have this
Sure.
link. I mean, take it, download it. There's not a lot of code here. It's just the buddy with 500 column. Now you see what is happening. You do a simple feature importance here, and You evaluate again. How am I doing the feature import? Let's see. Model selection. Okay. Feature importance ideal software. How does this behave? Again, feature importance also has. Yeah, this is permutation importance. All right. So it is giving me a feature importance based on a mechanism called permutation importance. There are other ways to get feature importance, like there's a tree-based algorithm which allows you to get features for trees, which is slightly better than this, as per my experience. And what it is simply showing is what feature holds what kind of importance. And as we can clearly see, the sepal width is not very important, right? And our previous accuracy was 0.93. Now, if I just remove this, which is what I'm doing here, I remove feature sepal length and retrain it, I'll get slightly, I thought I got slightly better accuracy. Just one second. So in one of the runs, I have gotten a 0.95, which was better than this. But uh, okay, crap. So again, this is not a very accurate way, great data set to demonstrate this. In fact, my accuracy has reduced after doing feature importance. But usually, what will happen is that once you eliminate a feature and after doing a careful study of it, your accuracy should and must have gone up. If it does not, then that feature importance probably needs to be relooked at. That's what I was trying to effectively communicate. Now, this is a poor example because every time I run this is such a short data set. It has just 150 records. So every time I run it, it's going to throw a absolutely crazy number. So don't, let's see. No, so I'm not getting it any better. So, but yes, supple width has low important, but it's still, let's see, I can probably do this. Let's reduce the number of trees. Does that help? No, it is not. So this is a small enough data set, so I'm not getting a good explanation of what I'm trying to communicate here. But effectively, when you do a feature importance and reduce the number of columns for a tree, and you have done your due diligence, definitely your accuracy should have gone up. Also, what will happen is if you have removed the number of features in a decision tree, your explainability also becomes higher. So that's the most important benefit for a decision tree or a tree-based model. There are any more questions, Vishal? Okay, I don't see them.
None
So
as of now. Yeah.
I think this is the best I had. I did not have a lot of time to do this, so I prepared this for about a 45-minute chat and few key takeaways. If you guys need to do that, read a little bit about Gini Index. That's really it will help you build an understanding of working with decision trees and how to improve a tree and how to interpret a tree and which tree is good and which tree is bad. And then just play with a lot of different combinations of your tree depth and as well as your number of trees in a random forest. These things could probably help you improve a lot on your random forest code. Let's see if it helps. Okay, no, it will not do anything. All right, that's pretty much what I wanted to talk about, Vishal. Or I can.
So yeah, one
Sure.
question
So,
is
what are
there for
some
you.
ways to think about dimensionality? Great question, buddy. So, dimensionality reduction is a topic in itself, and I'll be happy to talk about it provided I get some time. Dimensionality reduction, what it means is what I was doing here is a traditional, more EDA based approach to reducing the dimensions, which is to say that I looked at which is more important and removed the least important ones. This is one good way of doing a dimensionality reduction. But usually when you have that high number of columns, somebody was saying about 500 columns, What you should be doing is you should be giving your data a fairly good amount of understanding. You must be doing some kind of a separation, or you could run a dimensionality reduction model, either a PCA model, which is pretty linear, or a TSNE model, which let's say it separates your data in higher dimensions. In my experience, PCA has worked pretty much. You will lose certainly some explainability when you do onto techniques such as PCA and TSE when dealing with forests. But they will be a great way to get faster and get more accurate with a random forest. Because training a random forest or a decision tree is certainly a no-go for that large number of columns. You can go for a random forest, but again, that's more. It's a very large data. You have more than 1 million records and 500 columns. So you are better suited at something which is, let's say, neural network with a pinch of salt. You can definitely do random forest, but neural networks would probably be a better at modeling that kind of a large data set. Now, so thoughts about dimensionality reduction in random forest, you could typically do sampling techniques. You could typically do PCA, TSNE over your feature set. You should definitely also see the continuity and the type of the data your columns or the features has. Do you have categorical values? Do you have binary values? Do you have continuous values? Do you have timestamps and things like that? Make sure you uh, do some amount of pre-processing with it before feeding it to the model, and you clean your data. Again, cleaning data with 500 columns is not easy, and it's also computationally very challenging with that big of a data. I think for the buddy who had it, I'll just bring up my LinkedIn profile, and maybe if you want to talk about that problem specifically, we could chat offline, because that problem is typically very, very large. Is there possibility of getting bias errors in random forest? Yes, you could get bias errors in random forest. And bias errors could be, let's say that if your data is already biased, this is true for any, not for random forest. This is true for everything in the world in modeling, in machine learning. It's like garbage in, garbage out. If your data has uh, a bias, for example, if one of the classes is present much more than the other, specifically in binary classification, your data will get biased. There's also something which is called an imbalanced class problems, which are becoming very popular right now, and which is, let's say that mm, effectively your class bias will fall under those kind of problems. So, okay, let me see if I can find something on reducing bias in random forest. I don't have something off the top of my head, but limit overfitting. Okay, all the things that I see are talking over either bagging methods or doing a different sampling or a different random sample of the data. I'm sorry, buddy, not the best of answers, but uh, yeah, sorry about that. You could probably also try and increase the number of layers in each tree. That could also help you reduce bias to some extent, but again, it depends on the scenario and the data. How to decide number of trees to not overfit the data? There is no good. Uh, I, I I don't have a thumb rule around this. Usually, with the data sets that I have worked with, it have been significantly small. So I have usually worked with 8 to 10 trees and about 6, 7, 8 layers. But if your data is very large, then I think there could be some overfitting or learning of the data happening. The best is you do some exploration or exploratory and evaluation on the data. You make a tree, you see if it is really overfitting, because this tree, as you can see, is extremely inclined towards the whole right leg of it, even though there are enough number of samples. So out of 150 samples in iris data set, 50 of them fall under one class and the rest are distributed. So you could probably do a plot like this, and get the again Gini index of each of the class proportion and see which classes are making good sense, and then probably balance out your let's say layers of trees and the number of trees in a random forest should give you different results. And again, the goal is to see if you are specifically targeting certain classes, then you need to pay probably a little more close attention to those to the trees that lead to those classes. Alrighty, any more questions, Vishal?
Any other questions, audience?
So I
So,
gave the LinkedIn for me,
yeah,
Vishal,
yeah,
to
I
you.
shared it with everybody. They're free to connect with
Okay.
you.
So just feel free to connect with me. I'm sorry if I have not been able to have a very large exhaustive details on the topic because we also did not happen to have a lot of time. But I really
So,
did not want to cancel the session.
so we will be having more sessions by Akash uh, in June, probably June and July timeframe.
Yeah,
So,
sure, absolutely would love to. So I usually talk on NLP and I like NLP problems, word embeddings and I don't know, pretty much word embeddings, word to vec, glove, word, things like that, or traditional approaches to NLP. Still learning there, lot to do. So would be again connect me over LinkedIn for more details, and we'll be happy to help you out. Okay, so if there are no more questions, I think we can wrap this up, Vishal.
another one, small one, although I don't think
Mhm.
it will be feasible as of now, but you can probably name some problems
Can you please
which
give
we
a
can.
few problems to practice? Okay, yeah, but so okay, this is how do I say? So sklearn data sets. Because so whoever is saying you go and look at sklearn data sets. Okay, there's some lot of data sets available here. That real world data sets. You have a lot of different news group data set, which is very large vectorized data set. You could use this for categorization. Uh, sorry, classification. You can use this for, this is a very good data set for random forests. You will get very good visualization. You will get great fun at looking at this data. Just take this data set, go ahead and prune a tree, have some fun with it. That's it. I mean, these problems, again, I'll post it in the chat. These problems could be, these data sets are good starting point. I usually start here if I need to, but again, Kaggle is your friend. You can always look up Kaggle for more data and for more training examples. Okay. Anything more that is popping up, Vishal?
Yeah, nothing as of now. So, audience, this is a last chance if you want to ask any questions.
If you have, so I have 7 more minutes left on this talk, and I do not want to, let's say, leave or waste time. So you guys can ask anything in general to in machine learning if you have some holistic questions, and we'll just give it a minute. If nobody has a question, then I'll drop it.
So, I shared your LinkedIn. People are asking again. I'll just share again.
Okay. So my LinkedIn, do you want it
Yeah, I've
again
shared
or?
again. I've shared again.
Okay. Alrighty.
As mentioned, this webinar was being recorded and will be posted in 2 3 days time on our CellStrat YouTube channel. I'll just share the link of the same as well.
So guys, I mean, one small request. If you're sending me a detail on a request on LinkedIn, probably just put one small liner that we were talking about random forest in CellStrat meetup, so that I know and I can correlate to it because I see 3 requests and I do not know who they are. So request you to do that.
Okay, one
And I
question has come. Which algorithms are good on what in terms of bias and variance? Any response to that?
Sorry, which algorithms are good on?
Which algorithms are good on what in terms of bias and variance?
So decision tree, I will talk about the two I've said. Decision tree will have both variance because it's a just think of it as a smaller algorithm. It's a more it's it's a cuter algorithm. It's a smaller algorithm. It's a typical statistical formula. Think of it as a large dog when it's a puppy. Random forest is a grown-up dog. So random forest doesn't have these problems. But again, I would be saying it wrong if it doesn't have it. It's actually against how you control it, how you control out variance and bias. Bias can be controlled by data if your classes are balanced, if your data is pretty balanced, if you have given it the right data, then you do not need to worry about the bias of the class per se. Then what will happen is you'll need to see variance and handle the flow of that within the data. It could be that the sample that you have taken is just very small and your original data is very large. So all models, all machine learning models are uh, fit to bias and fit to variance, and there's always a trade-off between some bit of bias and variance, and that is our life. I mean, I don't want to comment saying this is better for this problem. I'm not educated enough to comment it that way. So sorry about that. But it's the answer from my side would be that you'll have to see and explore which model works out for you and how much of variance you are getting. And when you shuffle the data, when you do sampling, resampling, EDA, when you do some pre-balancing, what is it that you end up with? How much your model is accurate is what counts. Please, pruning techniques. Oh, sorry, I am not very skilled at pruning and boosting. So probably what I could do is I hope you have this link. I will the collab. I will put some code in the from a pruning technique standpoint in the same notebook. I don't think we have enough time for pruning techniques.
So I think uh, we are good to end the webinar. No more questions are coming. So thank you,
Pruning
Akash,
technique was a
for
good one, good
giving this
question,
webinar
but
on short notice.
no problem. You could, you could prune trees if you see, if you can visualize a random forest, or if you can probably somewhere do that visualization, and if you see that your certain trees happen to have longer layer depth and certain trees have smaller, you could just figure that out and you could limit your number depth of each tree to a probably lower number and see how it goes from there. This is something that is super easily done. But again, I cannot answer it. I'm sorry, buddy, in this short time. So thank you, Vishal. Thank you,
Yes.
everybody, for joining and staying. Bye-bye, everyone. Have a good night.
Good night. Good night, all.